happen. Okay. All right. So this is the final presentation in ecology. The topic is basically looking at strategies part 2. And if you remember, we had at the beginning of ecology, we talked about certain strategies to play the game of ecology, right? And the game is like you're trying to basically survive long enough to breed, to make babies, basically, right? And the strategies are basically things that organisms do to ensure that they are successful, right? So we're gonna like one of the things actually that came up, if you remember, is it better? Is it better to work in groups or is it better to work on your own, right? Because that's a strategy. So some animals work in groups, some animals work on their own. I'm going to show you an example of a really successful, probably the most successful animal other than humans, okay? And that's ants. So we find them everywhere. And we know that unlike cheetahs and unlike bears, ants are social, they work in groups, okay? Here's a really neat video of ants. And in this video, I'm not going to play the whole video. I'm just going to show you like bits and pieces of it. What they're trying to do, sounding kind of gross, they're trying to eat a slug. So a slug is this really, like relative to the ant, is a really large organism. The problem is as they try to eat the slug, they get stuck because the slug has this slime. So the ants actually get stuck in the slime. You can see here, it's kind of gross, I know. So you can see that this ant's head is actually stuck in the slime of the slug. So they have this problem where they're trying to eat an animal, but the animal is really, really, really sticky. You can see they're just getting stuck. So what's interesting about ants, if you remember, ants live in colonies, and they're often considered like what's called a superorganism. They have these tiny brains, but somehow they have this like these complicated behaviors, and sometimes they come up with some pretty ingenious solutions. So here's the solution that they come up with. You can see this ant is stuck. So now watch what happens to deal with this sticky problem of the slug. They start to cover the slug with mud and dirt. So what they do is they cover the slug in so much mud and dirt that the mud and dirt acts like a sponge, which wipes away the sticky slime from the slug. And now the ants can go ahead and continue, eating away. You can see now they're not stuck anymore. So that's a really cool example of, in this case, like ants working as a group. That's a really successful strategy for them. Now, not all organisms do this. Some organisms work on their own, and for them, that's good. Because the answer to these questions, what's the best strategy? There really isn't a perfect solution. What works for one organism might not work for another organism. So let me show you some examples of what I mean, okay? Armor. Is armor good? Wearing armor is good in some ways. It does offer protection, but the problem is it's very heavy and it's very bulky. So if I was wearing armor and my opponent had a bow and arrow, I would feel pretty good about my chances of surviving because the odds of the arrow being able to penetrate the armor is very, very, it's probably 0, okay? But the problem is if I'm wearing armor and the person I'm fighting has a cannon or a machine gun, I'm actually at a disadvantage, even compared to someone who doesn't have armor, because the armor is not going to protect me against machine gun or cannon. And I cannot run as fast as someone who does not have armor. So what may be good in some instances might not be good in others. So here's an example. This is an ancient fish called Dunkleostis. I think that's how you pronounce it. And you can see it's heavily armored fish. Okay, and you can see its size relative to to a person here. By the way, girls, are you seeing my screen? Because last time, we had an issue. Can someone just let me know if they're seeing my screen?
Yes, sir. I can see it.
Beautiful. Okay. So this ancient fish, you can see is really big. You can see the scale. Here's a person. It's about 30 feet long, but heavily armored. The problem with this fish is that because it was so heavily armored, it was quite slow, and maybe it was not able or fast enough to catch other organisms to eat. So, like, we can think of like turtles. Turtles are very heavily armored, but they're also not very fast. So being armored is good. It does give you protection, but it does make you slower. So there are, advantages and disadvantages. And that's the truth for all of these strategies. Advantages and disadvantages, okay? It does give you protection, but it is bulky, okay? And that could be a problem. Here's another question. Is it better to hide or is it better not to hide? So on the left is a very brightly colored frog. On the right is an owl that's blended in with the tree. You can see that. Now, the advantage of being able to hide, that's pretty obvious, right? If you hide, things can't see you. That's good protection, right? It's also a good way if you want to try to maybe catch some food. If they can't see you, you can surprise them. But some animals don't do that at all. Some animals actually, instead of hiding, they actually advertise themselves. And you can see on the left this really bright frog. That bright frog is not going to blend in to the background. So why would a bright frog advertise itself? Like, what's the logic here? What's the strategy going on? What is this thing trying to do? Does anyone want to take a guess?
Can we say like because the frog's skin is poison?
Okay, so yeah, very good. This frog is poisonous. So what it's doing is it's showing off its bright color as a warning. It's basically saying, here I am, I'm dangerous, and don't mess with me. What's really cool though is that there are organisms that also do this sort of thing. They are very bright, they advertise themselves, but they're not poisonous. They're bluffing. They make other things think that they're dangerous, although they're not. And again, this goes back to, for the frog, this strategy works really well. For the owl blending into the tree, that strategy works really well. So there is no perfect answer. What is it? Is it better to hide? Is it better to not hide? There are advantages to both. Here's another one. This is a bowerbird, okay? And what the bowerbird does is it makes, so you see the bird on the left, and on the right, it makes this beautiful nest. And what it does in front of the nest, it makes like it decorates it. Okay, you can see the decoration. What it's trying to do is it's trying to attract a female. Okay, now this is an interesting strategy. The strategy is let's build a nest, let's decorate it, and let's try to attract a female. Okay, now again, every strategy is going to have its advantages and its disadvantages. So what's the advantage? Well, the advantage of doing something like this, where you advertise the nest, is you are more likely to attract a female, right? And that's important because remember, what's the game? The game is trying to make babies, okay? So if the bowerbird doesn't do this, he's not going to get a female. The female is not going to visit him. Therefore, he's not going to be able to make babies. But what do you think could be a disadvantage for doing something like this? There's got to be a cost, right? Like this male bird is building this love nest. There's got to be some sort of a cost to doing that. Can anyone guess what the cost might be? Let's imagine that you're a little male bird, you're running around, you're collecting items, you're putting them in front of the nest. Do you think there could be risk to you for doing this?
Other animals like might know where like he's living.
Yeah, very good. Excellent. Yeah, perfect. By doing this, he's not exactly hiding, right? He's not doing what the owl is doing. He's advertising himself. Here I am. I'm making a nest. So there is a risk. But if he doesn't do this, then he won't get a female, right? And that's the whole point of the story. For every strategy, whether you're big or small, whether you're sexually reproducing or asexual, whether you work in groups or you work alone, there are advantages and disadvantages to these strategies. So here's another one about flying. We know that birds fly, but not all birds fly. And birds are not the only things that fly. But birds are interesting because there are lots of birds that don't fly. Here are some of them. Some of them are obviously extinct, thank God, because some of these are pretty scary. So what about flying? We know flying is good. We talked about flying actually a little bit because we talked about the dodo bird. Flying is good. I mean, flying, you can fly away from things that want to eat you, right? We know flying has its advantages, but it's also expensive because flying requires really big wings and it requires really big muscles. And therefore, when you have big wings and big muscles, you have to eat more. You have to eat more food. So again, even flying has its advantages and disadvantages. So not all birds fly because for them, it's probably better not to fly. An ostrich is a really big bird. If it had to fly, it would probably have to eat a lot more food than it does normally. So again, there are advantages and disadvantages. We talked already about this being bigger, right? Here's on the right a really cute elephant called a pygmy elephant. And you tend to find these on islands where there's not a lot of food because the problem with being bigger is you have to eat more, right? That's the problem. Dinosaurs were big. They were able to be big because there was a lot of food. The problem is 65 million years ago, an asteroid hit our planet, kind of blocked out the sun, plants died, the food disappeared. So what survived were the tiny little mammals, top left corner, things that you can see were the size of a paperclip. Those are the things that survived because when there's not a lot of food, being big ain't good. When you're on an island and there's not a lot of food, you don't want to be a big elephant. You want to be a small elephant. Okay, once again, the story is being bigger has its advantages in certain circumstances. Because if you're bigger, there are less things that can eat you. But problem is, if you're bigger, you need more food, which is a problem, right? So advantages and disadvantages. What about parenting? Oh, look at that cute pictures, right? Is it advantageous for animals to parent? By now, you should realize the answer is, on the one hand, yes. On the other hand, no, right? Advantages and disadvantages. And by the way, even some frogs parent. So is there an advantage? Yes, of course there's an advantage because when you parent, you take care of the young, which means the young are more likely to live, right? If you feed them, take care of them, protect them, they're more likely to survive, which means they'll grow up and they'll have their own kids, and that's better for everybody, right? The problem is parenting is expensive. I mean, you have to spend time to watch the eggs. You have to be willing to protect them from other things that might want to eat them. You have to feed them, right? It's expensive. pros and cons, right? Advantages and disadvantages. And sometimes animals actually take advantage of this. Going back to ants, ants are very social. They have a very complicated network. They're controlled by the queen, right? She gets to breed. She has all these people working for her. Certain people, I said people, ants. Certain ants take care of the babies, right? Parenting, expensive. But what's really cool in this picture is that this ant that you're seeing is actually been tricked. It's actually taking care of something that's not an ant. This is actually a blue butterfly baby that has actually tricked ants into raising their own babies. So just jump in here. What kind of a trivia question? What kind of a relationship is this between the butterfly and the ants? Remember we talked about symbiotic relationships? The three types are mutualism, commensalism, and parasitism. So which relationship is this one that's taking advantage of the ant's parenting? Anyone know? So the butterfly is benefiting because the ants are protecting their baby or its baby, and the ants are being harmed because they're taking care of something that's not their own. So this would be an example of what?
Parasitism.
Very,
right?
yeah, excellent.
Okay.
Yeah, parasitism. Very good. Parasitism. Excellent. Yeah, because the butterfly is benefiting and the ant is being harmed, right? Being taken advantage of. So again, but going back, parenting has its advantages and disadvantages. That actually leads us into the next slide. So we can divide animals into two groups, okay? On the one, they're called R strategists. On the other hand, they're called K strategists, okay? So an R strategist is typically an organism that has lots of babies but doesn't take care of them, okay? And you have examples like fish and oysters. Now, there are some fish that do take care, but 99.9% don't, okay? Most frogs don't, but some do, okay? On the right, you have animals that have less babies and they take care of their babies. So the ones that take care of their babies and have less babies, those are called K strategists. The ones that don't take care of their babies and have lots of babies, they're called R strategists. Okay. Now, if I ask you what's better, is it better to be a type of animal that has few babies but takes care of them, or like a K strategist, or is it better to have lots of babies and not take care of them, which is an R strategist? You should know by now the answer is it depends. It's good, being R is good on the one hand, but on the other hand, it's not good. It's good because you have lots of babies, right? Remember, the game is what? The game is to produce babies to get your DNA into the next generation. So one strategy is have as many babies as possible, because the more babies you make, the more copies of your DNA get passed on. That's a good strategy. The problem with that strategy is a lot of those babies die because you don't take care of them. The opposite end is, the K strategy says, you know what, we're going to have less babies, but we're going to make sure that the babies survive. That's a totally different strategy, okay? And you can see the connection between the strategies and what's called the survivorship curve. So I'm going to just go look at the two exact opposite strategies, curves. So one is something called you can see it here, it's called a type 1 curve. And the way you read this is if you follow the type 1 pattern, that means that when you're born at time 0, okay, the chances of you dying are very low, okay? Because you can see here that this is the number of survivors, okay? So in other words, you don't die, okay? You can see you don't die, you don't die. You only start to die when you get old, okay? That's one pattern. That's what things like humans and chimpanzees follow, and elephants. These are all things that are K strategists, okay? The reason why they follow that pattern is because the babies are taken care of, all right? Now, if you compare that to a type 3 curve, which is this one, you'll notice, if you look at the number of survivors, it drops immediately. What that means is that a lot of those babies die. Okay, a lot of those babies die. So when an oyster, which is an R strategist, or fish, release lots of eggs, most of them die. And the reason why is because the R strategist, which follows the type 3 pattern, okay, this is the R strategist, they follow the type 3, and the K follows the type 1, because the R strategists do not parent. Because they don't parent, most of those babies die. But again, what's the better strategy? There isn't one that's better versus the other. They both work, okay? They both have advantages. They both have disadvantages, all right? The last, so that's just summarized here, okay? So the last topic then, last example of is it better to be? And the answer is it depends. Is it better to be a generalist or a specialist? So here you see pictures of birds and their beaks. The beaks have certain shapes because it all depends on what they're trying to eat. So on the left is you can see the beak is very, very thick. On the right is a beak that's very, very thin. So probably the bird on the right eats things that are like little seeds that are not very tough, small little seeds. Whereas maybe the bird on the right eats something that's very big, maybe something that's very hard to crack. These are examples of specialized beaks. So the question is it better to be a generalist, something in between, something that looks like its beak is not too small, not too big? Is it better to be something that's generalized or specialized? And I hope you know the answer by now is it depends. So on the left is the raccoon, okay? The raccoon, the ninja of the backyard. The raccoon is a generalist. It can eat so many different things, right? It could eat plants and animals and different types of animals, different types of plants. It could steal food from your backyard, and it can break into your house. And okay, maybe not. Well, maybe it can break into your house, but on the right is an example of a specialized, highly specialized organism, the anteater. All right. Now, pros and cons. The anteater is very good at what it does. Right. It's very, very good at what they do, their job, which is called their niche. They're very, very good at that. And if anything tries to compete with them, so if a raccoon was to try to compete with the anteater by trying to eat ants, the anteater would kill it. Not literally kill it, but it would like just win that battle. If there was competition between the raccoon and the anteater for ants, the anteater would win. All right. Because they're specialized. It would be like saying, if I have a degree and I go to university, I learn a little bit about everything. I learn a little bit about science and math and English and religion, and I go apply for a job. But there's another person also applying for this job, and they're a professor of science. Okay. They did a 10-year program at some university, and the job that we're applying for is to be a professor. Well, I ain't getting that job. There's no way I'm getting that job because that other individual is specialized, and this job requires a specialized individual. So in that case, it's like the anteater. You know, if these two animals were competing for ants, the anteater would win. But what if the job was not for a professor? What if the job was for an elementary school teacher? Then what they're going to want is someone who knows a little bit of everything, right? In that case, the generalist would actually win out. So again, what's better? It all depends. If the diet is like, if there's a lot of different things out there that can be eaten, maybe being a generalist, maybe having the flexibility is an advantage. So we can think of this scenario. Imagine all of a sudden there were no more ants. Now, you're an anteater, you eat ants. For some reason, the ants are gone. That's a big problem because the raccoon doesn't have that problem. The raccoon is a generalist. So if it doesn't eat ants, it could eat other things. So therefore, in that case, being the generalist, you know, would be a major advantage. Okay. Oh, I think I remember I left. Oh, I was supposed to fill in this slide. Now, oh, I can't remember. I was supposed to ask you a question about viruses. I never putting this down. I never finished putting in this slide. I can't remember what the question was, but I think I'll stop here. Okay. So let me stop the recording, and I'll take questions.